Hey everyone, welcome to your play posit for the day. We are going to be starting, actually it's for the week, but we're going to be starting the very last unit in your geometry course. So that's pretty exciting. This is our introduction to trigonometry lesson. And so go ahead and grab your notes, have that play posit graded assignment open, and we'll get started. One quick reminder is that we have our benchmark test next week. You guys will have your math test on Monday, and then your ELA test on Tuesday, and then Wednesday, whether if you are in 7th grade, you'll have your civics, and if you're in 8th grade, you'll have science. So we organize this for you guys so that way you could space it out and you wouldn't have any other lessons or classes on those days. But the tests will be available for you. So take them, I want to say at your leisure, but at the minimum, have your math done by the end of the day Monday, have your ELA done by the end of the day Tuesday, and then these done by the end of the day Wednesday. I plan on having our math benchmark in there by 3:25 because I've had a few students who've messaged me saying they're going to be going out of town. So if you do log into USA Test Prep, you'll see that, and you can choose to take it early if you want to, or you can just wait until Monday and take it on Monday. So here we are. We are going to learn how to solve trig functions with trigonometric ratios. That's a fun word to say. Trigonometric. Try it. Trigonometric. And I feel like I've shown you guys this bear before, but he makes me so happy. Have you heard that phrase, be there or be square? Right? So he's like, be there or be square, they said. Should have gone to the party. Should have listened. I thought, nah, that's not going to happen. Now look at me. He's a square bear. Poor guy. Or girl. Or bear. All right, so let's quickly review some things about right triangles. So they have some special properties, right? We know that this is 90 degrees. That square tells us it's 90 degrees. It's like the, universal geometric symbol for a right angle. And the side across from the right angle has a very special name. And we learned this when we did the Pythagorean theorem. You guys remember this is called the hypotenuse. And then when we learned the theorem, the other two sides were pretty much, the leg and the other leg, like leg 1, leg 2. It doesn't really matter, right? Well, you're going to see when we talk about trig functions that the names of the other two sides will matter. And we're going to be able to determine the names of those two sides with something called the angle of perspective. So when you see this word perspective, what do you think of? Like, I think of the way I see things, the way someone sees things, right? So when we're talking about trig functions, the angle of perspective is going to help us, if I can spell, help us determine the trig ratios. Now, trig is just going to be shorthand for trigonometric or trigonometry. So you'll hear me say trig a lot. And then remember, a ratio is just a fraction. So a trig ratio is just a fraction. And the angle of perspective is going to help us write those fractions. So whenever you're trying to determine the angle of perspective, I like to pretend I'm standing at one. So maybe I'm standing here. And we're going to label the sides of the triangle with these sort of new names for the angle of perspective. Now, the cool thing is that this side's name never changes. This one is always the hypotenuse. Hypotenuse. And I'm going to abbreviate that to HYP from now on. So that does not change. But look at this. If you're standing at angle C, get a different color, and we were going to label the other two sides, what do you guys think this side might be called? So pretend you're standing here, you're looking that way, you're looking across. You're looking across the triangle. So this side is opposite you. Opposite. So this is now the opposite side. But only because it's where you're standing. You've chosen, or we've chosen, C as the angle of perspective. So when we're standing at angle C, or this angle here, that's the opposite side. And then lastly, we're going to label this side BC, and this side is right next to where I'm standing. So we call this one adjacent. It is right next to me, ADJ. So I want to point out, well, what if we decided to stand at angle A? What if angle A turned into be our angle of perspective? That's totally allowed, but it would change the names of our labels. Because if I'm going to stand here at angle A and I'm going to look across the triangle, then it just so happens BC ends up being my opposite. And AB ends up being my adjacent. But you guys see how the hypotenuse never changes? It never changes. So, do you think you're allowed to stand at angle B? Is angle B, or the right angle, allowed to be the angle of perspective? Never. Because if angle B was the angle of perspective, then we would be looking across the triangle and this would become opposite. But no, this is hypotenuse. This can't be opposite and hypotenuse. And we said it's always the hypotenuse. So that is why the 90-degree angle can never, ever be the angle of perspective. That's super important. The 90-degree angle can never be the AOP, the angle of perspective. And that's simply because that side already has a label, already called the hypotenuse. So we can't change it to opposite. It's just not allowed. So the angle of perspective is going to determine the trig ratios. So it's important that we label the sides properly. And you can choose either of the other two angles, depending on what the problem gives you. So I'll show you some examples. Before we do that, we're going to talk about each of the 3 trig ratios for this year. There are a total of 6 trig ratios, but in geometry, you're going to learn 3. When you guys get to Algebra 2 trig, you'll learn the other 3. So the first one, we call it the sine ratio. So sometimes you'll see it written out like the sine, but the abbreviation for it is SIN. But you won't hear me say sin of angle C. So that's kind of funny. Like if I see this, I'm still going to read it as sine of C. And of course, if you guys get on the microphone or you're explaining a problem, I will never be upset or correct you if you say sin C. Like it's just, I get it. You're reading the word. I totally understand. The more that you work with these, it'll become sort of second nature. Oh, that's sine of C. So I don't really know why. For some reason, they decided to drop the E with the abbreviation, but I think that's because they were trying to make them all 3 letters, and you'll see the others. The others are longer. So the sine ratio, or the sine fraction, is a comparison of the opposite to the hypotenuse. So we're just going to write that as a fraction because that's what a ratio is, right? And again, it's totally up to you. If we picked angle C as our angle of perspective, then let's label our triangle. We know that AB is opposite, right? It's directly across. Across from the right angle, that's always the hypotenuse. And then the other one is next to it, the adjacent. So sine of C is opposite over hypotenuse. The fraction. So let's say I gave these sides some values, like a 3, a 4, and a 5. We know that triangle. So sine of C, we chose C as the angle of perspective. That's why I wrote C, and we circled C, is opposite. Opposite is 3, and hypotenuse is 5. That's it. So you're just identifying the angle of perspective. And in this problem, they did say, okay, go ahead and use C. We could also do sine of A. and we could relabel it. So we could pretend like we're standing at angle A, and I'm going to make this purple. So that would make this side opposite and this side adjacent. See how that changes? And then opposite would be 4 and adjacent is 3. So sine of A is a different value because it's a different angle. And then can we use B as the angle of perspective? And the answer is no, never, ever. Don't do it. Don't fall into the trap because angle B already has a very important forever label, the hypotenuse. Whatever the one is across from the right angle is always the hypotenuse. Okay, let's try another one. Let's go to the next. Actually, we could do an example here. I have 2 pens here, and I think I like the thicker one. It says find the sine of x and the sine of y. So they're asking you for a specific angle of perspective. They give you x. So we'll start with that one first. I'll make this one orange. So I'm going to label my triangle with the orange. This is always the hypotenuse, right? It's across from the right angle. That makes 8 opposite x, and the other one is adjacent. It's right next to it. So the sine of x is, remember, sine is opposite over hypotenuse. So all we do is we take the opposite value, that's 8, and put it over the hypotenuse value, that's 17. And that's it for now. Let's do the other angle of perspective because they want y. So I'm going to circle y and make it blue so we can keep track. That makes this opposite and this adjacent, and hypotenuse stays the same. So sine of y now is opposite y is 15, and next to y, or adjacent to y, is, I'm sorry, hypotenuse. Hypotenuse is 17. I don't know, I'm thinking of tangent. Okay, so sine is opposite over hypotenuse. Opposite of y is 15, and hypotenuse is 17. And that's it. We're done with number 1. Let's try number 2. So first we'll use x as our angle of perspective. So that makes 15 opposite x. 25 is the hypotenuse, right? That's across from the right angle. And 20 is adjacent. So sine of x is opposite 15 over hypotenuse 25. Oh, we could reduce that, right? Divide both of these by 5, so that's 3 over 5. Sine of x is 3 over 5. Okay, let's do the last one. They want sine of y now. So the only thing that changes now is that 20 becomes opposite and 15 becomes adjacent. So it just depends which angle you're looking from. Which angle is the perspective angle? And that angle is always going to be the one given to you right next to that trig function. So sine of y is opposite y, that's 20 in this case, and hypotenuse, 25. Which again, we can reduce that, right, to 4 over 5. Cool. Now let's do cosine. So here we go. Here's the whole word spelled out, and then you can see the abbreviation is COS. So again, you'll still hear me say cosine of C. You won't hear me say cos C. It's just kind of like a thing. But cosine is the comparison of the adjacent to the hypotenuse. So this time we're still going to use C. That's our angle of perspective. We label it the exact same way. So opposite here, adjacent, and hypotenuse. So cosine is adjacent over hypotenuse. So you literally take the number that's on the adjacent side and put it over the hypotenuse. So let's put some numbers just as an example. We'll do 3, 4, 5 again. If we're using C as the angle of perspective, then cosine of C is adjacent is 4 and hypotenuse is 5. And that's it. So let's try some examples. It says find the cosine of U and the cosine of W. Write each answer as a fraction in simplest form. Okay, so first we're going to let that angle of perspective be u, because we are trying to find cosine of u. And sometimes you'll see it written like cosine of u, sometimes you'll see it written cosine of angle u. They're both fine. So opposite u is 24, right? And then we have our hypotenuse. I feel like those are the two that are like super easy to label at first, like very visual to me. Sometimes people get confused with adjacent, but if you label those other two first, then adjacent's like the only one left, right? So remember the cosine ratio is adjacent over hypotenuse. So if we're standing at u, we're just going to take the adjacent number, that's 18, over the hypotenuse, that's 30. And these can definitely be reduced, right? I think by 6, right? 18 divided by 6 is 3, and 30 divided by 6 is 5. I think we could just reduce that whole triangle probably to a 3, 4, 5, huh? Yeah, you could even do that from the beginning. Let's do cosine of W. So I'm going to pick a different color, and we're going to make W our angle of perspective. If leaving the other labels on there messes you up, you can definitely like just resketch the triangle. No big deal, right? Or you could erase them. Look, I just resketched that pretty quickly. Let's make W our angle of perspective. And so that makes 18 opposite, 30 hypotenuse, and 24 is adjacent, the other one. So cosine of W, remember, is adjacent over hypotenuse. So once you have it labeled, you're just like picking the numbers off of it. And this can also be reduced, right? This is 4 over 5 by 6. Yeah. 6 into 24 and 6 into 30. There we go. So this is a 3, 4, 5 triangle, a multiple of. Last but not least is the tangent ratio. So again, here's the word tangent, and it's abbreviated to tan, but you will not hear me say tan C. You'll still hear me read this as tangent of C. So tangent is the comparison of opposite to the adjacent. Opposite over adjacent. So again, let's make C our angle of perspective. We have opposite, adjacent, and hypotenuse. We can give these some values. Let's just make things up. 7, 12, and 9. How about that? So tangent of C is, opposite of C is 7, and adjacent is 9. And that's it. But remember, it all depends on what your angle of perspective is. If they said to let the angle of perspective equal A, that changes your answer completely. So make sure that you're choosing the right angle of perspective and you're labeling the triangle based on that angle. So let's try some. Find the tangent of J and K. So first we'll start with J and label our triangle. The labeling of the triangle is the same for any of these trig ratios, right? You always just pretend you're standing at the angle and then label the sides. The part that's different is when you go to write that fraction, that ratio. So here's the hypotenuse and here's adjacent. So I'll put it up here. Remember, tangent is opposite over adjacent. So in this case, tangent of J is, we've labeled it, so we're good to go, 24 over 32. And again, I'm guessing this can be reduced by what? By 8 maybe? Yeah, okay. I'm not usually very good at that. I have to think about it. So 8 into 24 is 3, and 8 into 32 is 4. Oh my gosh, is this another 3, 4, 5? Yes, that's crazy. All right, let's do K. I'm just going to do another color. Remember, you can rewrite the triangle if you want. You can erase things if you want. Just don't get them mixed up. So we're going to make this now opposite and this now adjacent, and hypotenuse stays the same. So tangent of k, remember tangent is opposite over adjacent, so we're going to have 32 over 24. So that's just going to be 4 over 3, right? It's just that sort of reversed ratio. Okay, number 2. We're going to start with j this time in red. So we'll have this is opposite, 15 is adjacent, and 17 is hypotenuse. So once you have it labeled, it's just remembering the ratio and then plugging it in. So tangent of j is opposite, which is 8, over adjacent, which is 15. And that's it. That cannot be reduced. And then we can do k in purple. So that makes 8 adjacent and 15 opposite. So tangent of k is opposite. I always say it out loud still. 15 over adjacent is 8. There we go. All right. So just kind of a recap, we're going to review everything, and I wanted to share with you guys a mnemonic device that has helped me ever since I was your age, and it's Sohcahtoa. Check this out. Oh, I spelled that wrong. One moment, please. How did that even happen? Okay, Sohcahtoa. S stands for sine. O is opposite over hypotenuse. See that? It's a way to remember the ratio of each. I love it so much. I use it every day. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Sohcahtoa. I guarantee you, you will never forget the trig ratios if you remember Sohcahtoa. And you can even just, sketch it down on your paper, Sohcahtoa, and then the first letters, like just spell out exactly what it is. So sine, again, is opposite. I even say it in my head. Sine, so, O and H. Cosine, ca, adjacent and hypotenuse. Tangent, toa, opposite over adjacent. I promise you it will help. And in this case, we were using that angle C. Remember, you can use angle A, but you cannot use angle B. Something you should know is this is also on your formula sheet. Yay! So you actually don't have to memorize it. I still think Sohcahtoa helps. And I wanted to show it to you on your formula sheet because it's written the same but different. So here they have the Greek symbol theta, and that's just a symbol for an angle. They could have called it C. They could have called it X. They could have called it whatever. They decided to call it theta. So that's just their angle of perspective that they chose. So with that angle of perspective, they labeled their triangle opposite, adjacent, and hypotenuse. And then they showed you, based on that triangle's labeling, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So you have the ratios here. It is written slightly different. I mean, not really, but they're using just the first letter, OH, and they're using theta instead of C. So I wanted to point that out to you guys if you were like, what is happening on my formula sheet? Okay, so let's use this to actually solve for some things. So step 1 says to pick the angle of perspective. So let's label this triangle ABC. Well, we can't choose C because we're not allowed. You're allowed to choose A or B. And I would say that it's best to choose the one you know. And some of you might be going, well, I can find B. And you totally can find B. You guys have the skills to find B. Remember, a triangle adds up to 180. So if we know two angles, you can always find the third. So you could definitely do that. But to skip that step, I'm just going to choose the angle that we have. I'm just going to choose A as my angle of perspective. And I'm going to go ahead and label my sides based on the angle of perspective, which is what we've already done before. So that makes this opposite. This is always hypotenuse, and this is adjacent. Step 3, decide which trig function to use. Sohcahtoa. I'm telling you. Sohcahtoa, it will save you. So we're looking for x. So we know we have to use something with hypotenuse in it, right? So we can't use tangent. Tangent only has O and A. We need H. We need a H one. So it's either going to be sine or cosine. So what else do we have? We have O. We have opposite. We have 14. We don't have the adjacent number at all. So we want to use the one that has O and H because that's what we have and that's what we're looking for. So which one has O and H? And that is sine. So let's set it up. Sine of what? Sine of A, our angle of perspective. Well, what is A? Oh, it's 51. Okay, sine of the angle. We know the angle, so we're going to put it in. And remember, sine equals opposite over hypotenuse. So opposite is 14, and hypotenuse is x. So check this out. Sine of 51, you guys, don't let this bother you. This is just a number. I'm going to show it to you. Let's go to a different tab. Let's go to Desmos. Sine of 51. Look, you can literally type it. SIN 51. Sine of 51 is 0.777. It's just a number. I promise you. It's just a number. So if it's just a number, that means we can solve this for x. We're going to solve this just like any other equation. And it's kind of up to you, right? There's a few ways to do it. I might cross multiply. So x times the sine of 51. Remember, sine of 51 is just a number. We'll keep it all together. Equals 1 times 14. This whole thing is a unit. You cannot separate like the s and the I and the n. It's a whole function. It's a number, right? It's 0.77. We saw that. So now to get x by itself, we're just going to divide by this whole thing. So x equals 14 divided by sine of 51. So let's see what that is. What is 14 divided by sine of 51? It's 18.01. Let's do that. That's it. It's 18.01. Let me make sure one thing. This is the Virginia calculator, so that's good. The Virginia calculator is always in degree mode, which is what we want, right? Because our triangle had degrees in it, right? It had 51 degrees. But you won't have to worry about that. As long as you're using the Virginia calculator, it's always in degree mode for you guys. So it's just 18.01. That's the answer. Whatever the units are, I guess we'll put units because, you know, it could be centimeters or miles or inches since that's the hypotenuse. So I don't want you to worry. Sine of 51 is just a number, and we use our calculator to help us find it. Okay, let's try another one. Find the missing variable. So we do the same thing. We're going to pick, if you want to, we can label this whatever you want. I'm going to pick an angle of perspective. Again, it's up to you if you want to pick A or B. I'm going to pick B just because it's already there. And then we'll label well, we can label everything, right? So we know this is hypotenuse, this is opposite, and so this must be adjacent. It's right next to B. So then I always go like this. Okay, Sohcahtoa, I need X, right? I need H. And I know A. So I'm going to need one that has A and H in it. The only one that has A and H in it is cosine. It's c. So Saying it out loud helps me write it. Adjacent over hypotenuse. There's the A-H. So there we go. Let's do cosine of the angle. The angle is 59. And adjacent is 34. And hypotenuse is x. If you really wanted to, you could go ahead and replace cosine of 59 with the decimal if it bothers you that much to be carrying this around. I know some people are like just bothered by it, but I promise you it is a number. You saw, like if we go to the calculator and put cosine of 59, it represents a number. It's 0.515. That's it. So I hesitate to suggest that because it's better to do it at the end so that way you don't lose any of those decimal values if you round too early. So I'm going to keep it. Let me grab a different color. Okay, so let's do our cross multiplying. X times the cosine of 51. And you don't have to, or 59, sorry. You don't have to put this in parentheses, but I'm just doing that to kind of show you that it's all one thing. And then we'll divide by cosine of 59, both sides. So x is whatever that is. Let's go to our calculator. 34 divided by cosine of 59. What is happening? Hold on. Okay, 66.01. And you guys are never going to have to do this by hand. I'll tell you what, I had to do this by hand in college for my first year. We had trig tables. They were so long. They were pages and pages long. I mean, it was basically like a calculator on paper. We just went to cosine of 59 and looked over and saw what the decimal was. So it really is the same thing, but it's just nice that you guys have the Desmos calculator to get like an instant answer. Okay, let's do another one. The steps are the same. We're going to pick an angle of perspective. You can literally pick the whichever one you want except for 90, right? So you want to change it up this time? Let's pick the angle we don't know. And let's find it real quick. We're going to do 180 minus the other two, 37 and 90. And it's 53. So I'll put 53 there. And then I'm going to label the triangle based on that angle. So I have opposite, hypotenuse, and adjacent. So according to this angle, let's write Sohcahtoa. Sohcahtoa. So I need X, I need A, and I have O. So I'm going to need the one that has A and O. A and O is TOA. That's the only one. So I'm going to use tangent. And the OA helps me write the fraction, the ratio. So tangent of 53 equals opposite 12 over adjacent. And let's go to town. We do x times tangent of 53 equals 12. And then divide by tangent of 53. What's 12 divided by tangent of 53? I have no idea. 9.04 units. And I want to show you something this time, you guys. I want to show you what would happen if you did pick 37. So let's try it with 37. And we would need to label this opposite and adjacent. So we still have O and A, right? So we're going to do tangent of 37 equals opposite over adjacent. Now this one, it's just a different ratio. So we can do the same thing though. 12 times tangent of 37 equals x. Because x is on top here, we don't have to end up dividing. But you solve it the same way. So let's see what 12 times tangent of 37 is. Oh my gosh, it's the same thing. It's amazing. 9.04. And it should be the same thing because we were looking for the same side. We just chose a different angle of perspective and set up a different ratio. So I wanted to show you guys that it can be done with either angle. So now it's your turn. I have a question set up for you guys in ClassKick. I will put that link for you somewhere you can access it. Ideally in the Play Pause it will pop up. And if you're not watching the Play Pause I'm also going to put the link just in our assignment folder. So it'll be there for you. And you're going to want to click the link, enter your first name and last initial as it appears in new row, and then just complete the question. So you don't have to log in. You just have to literally, here, I'll show you what it looks like because we can. One second. It should pop open, I hope. I might need to change my tool. There we go. So it's going to pop open and it's going to tell me to continue. I'm going to continue to ClassKick. And look, all I have to do is type my name. Winslow J. And click go. As soon as you click go, the screen will appear for you guys to do the problem. And just follow the steps. It wants you to solve for the missing variable and also drag these to label. So you can choose your angle of perspective, whether it's that one or this one. You can label the sides and all that. And then you'll click to the next slide, you go to thank you message, and you don't have to submit anything. See, there's nothing to push that says submit or I'm done or nothing like that because ClassKick automatically saves your work. As soon as you put your name in that first screen, you're in, and that's it. That's all you have to do. All right, so just to kind of give you a look ahead, this is what we're building towards, not this year, but in your following years, likely Algebra 2 Trig, so not even next year. But you are sort of on this path. I don't want you to think we're learning these random trig functions for no reason. This is called the unit circle. And I promise you it is not as maybe complicated as it seems. I promise you. You can probably already see some things that you recognize. And we're going to talk about that on Thursday. I don't want to give too much away. So thanks for sticking with me, you guys. I hope that you're finding trig will be a fun and not easy, but doable unit for our last unit of the year. And I'll see you guys on Thursday. Bye, everybody.